This is Hi guys. This is a quick introduction into the Maxbox problem. You've got a document attached to the lesson, Maxbox Investigation 1. It's about if you were given a piece of paper, and I'll show you, and you would try and make an open box, so there's no lid to this. What's the biggest volume you can contain within it? Okay, so what you're going to have to do is, you don't have to cut off the corners, but if you were to cut into a corner to make a square at each edge so that the heights of these walls are all the same, all the walls need to be the same height. It's wasted paper if you don't make them the same height. So what's the maximum height? What height can you make to give us the greatest volume inside this box? Okay, so I'll just do a quick demonstration of exactly what we're doing. So I've got a square piece of paper. If I was to measure in from the ends, I'm going to use a ruler. So we measure in and we get the same distance in from each edge and each corner. Sorry about the quality for this bit of the video. The camera used for this part is a lot lower resolution, for which it's a bit out of focus. That's better. So you can now see those. So if I was to just cut in at right angles, I hope you all realise I don't need to cut along all the edges on the sides as well. I'll just fold these in. Maybe the folds but should have been done first. There we go. See, I don't always know everything off the top of my head, just most things. So if I was to fold these all in to make a box, what's the greatest capacity, the volume inside the box? If I fold it up, hopefully you can see I'm now starting to get a box that has space inside it, and I can fold it in on both sides. Okay, so we're going to try and make, we're not actually needing to make the boxes, but I've now got a box made out of a piece of flat paper by cutting equal lengths in at the corners. Okay, so that's what the problem is doing. So the first thing we've got to do is we've got to actually try and make a list of possible values, and I've given you a spreadsheet to help you. Now you can, I don't mind if you do one of two things. I don't mind if you work out each length individually and calculate the volume by doing a calculation on your calculator. We can do calculations based upon using various values. So this is the piece of paper I've been given at the top, 29.7 and 21. We've got another problem a bit later. Both these numbers are changed to 12. That's where we're trying to use a square piece of paper. So if I do a corner cut of 2 centimetres, the first question in the document is asking why. So the corner cut is 2. So if this cuts in 2, what's the height of this box going to be? And then if I was to do that cut of 2, why is this 25.7? Well, if I do 29.7 and I cut 2 centimetres off it, why is the actual width of this going to be 29.7 and the length 17? Okay, so we then go around, we cut out a few more volumes, calculate the volumes. There's a couple of questions going through to help prompt you, but I'd like you to try and work out what is the maximum volume we can create. So to calculate the volume, now this is how you can enter into spreadsheets a formula. You press equals, and then for each cell you want to use, I want to use 2. What do I do with that to calculate a volume? Well, if I'm looking at the end being this end, So I've got 2 times the length, gives me the area on the end, then multiplied by the length going backwards, which we'll call was the width. I can calculate the volume of that box. And we can keep going through. I could do another calculation, let's say 10 centimetres, and the answer for that one is going to be 9.7. You can create a formula. So once you've worked out why this is 25.7 in this one, you can create a formula for this, doing the equals trick. Oh, shouldn't be 10. Let's go back a moment. Something weird happens with something like 10. Oh no, 10 will be fine. We've got 9.7 left, 1 there, and I can copy the formula down. So if I copy that formula, because it's got no stars, dollar signs in it, all these cell references will move. So copy that and put it into there. And it's now calculated the volume as 97. So clearly it's gone down from 2 centimetres. So if we make the cut at the corner of 2, the volume is 873 centimetres cubed. If I make the corner cut 10 centimetres, it goes down to 97 centimetres. If I want to create a graph for this, what I can do is I can go up into Insert, Chart. Over here it will give us the setup. We don't want column data. What we're looking for is either dot plot, so we've got the corner cut and the volume plotted, or we can use a line chart, or even this curve chart, this smooth line chart. It will try and guess better values in between. Okay, I don't mind which one you use. So because I don't mind, I'm going to do the simplest one, which is that one. My x-axis, if I click on that, let's select the range. Well, the x-axis is my x values. So I select all the x values, say OK. And my y, the series, or the other range I can add is my volumes. Okay. So now I've got 2 points plotted. I can calculate more and more volumes going through, and I'll get a graph. And from that graph, at the moment you can see the best is going to be the 2. My best volume is if I use 2 centimetres. Do lots more calculations and see if you can find the best value you can. Okay, that's the exercise for the day.